Hey, geometry people. Today we're going to extend what we did with circles, with circumferences and everything, and we're going to talk about arc length today. So here we go. And oops, got to erase. That's not arc length. Okay, so circle arc length. So if we think about the circles we've been talking about, arc length is just a piece of the circumference. So sometimes I might just want to know the length of a part of a circle from here to here instead. So if that's the case, I need two pieces of information. I need to know what this angle is, and I need to either know the radius or the diameter. So I need to know this angle, and I need to either know R or D. And so the formula for the arc length is a lot like the formula for the circumference. So we know circumference is pi times diameter, or 2 pi r. And so the arc length is just a portion of that circumference. It's a fraction of it. And so if I take the angle of my arc and divide it by 360, since there's 360 degrees in a circle, that's the percentage, or the fraction, I guess, not percent, but fraction of the circle that angle covers. And so that would be the fraction of the circumference that I want. And so then you can either have it times pi times diameter, or times 2 pi r. Either way, you're going to take that fraction and multiply it by your circumference. So let's try one. Let's say we got a circle, and I want to know this arc length, and this angle is 47 degrees, and my radius is 12 inches. Okay, so now all I have to do is plug these in there. So we're given, first of all, we want to identify what it is that we have. Do we have a radius or a diameter? So in this case, we have a radius. If I had a diameter, I could either cut it in half and use that, or if I could use the equation with diameter in it, either way. And then here's our angle theta, 47 degrees. So 47 over 360, since I have a radius, I'm going to use that one. So times 2 times pi times 12. So that's what we're going to type into our calculator. So let's go. To pi 12. And we should get 9.84 inches. All right, so that would be the length of just that portion of the circle. Okay. So the next thing that we would want to be able to do is kind of play around with how we get our information here. So sometimes it won't always be given directly as the radius and the angle. Sometimes we'll have to be a little bit creative here. Like, let's say, that's not the center of the circle, but we're going to pretend it is. Let's say I want to know this arc right here, but I know the diameter of the circle is 20 meters, and I know that this angle around the outside here is 301 degrees. Well, then we've got to do a little bit of solving to get our information here. So if this is 301 degrees, the whole circle is 360 degrees. So that would tell me that my angle inside here is just 360 minus 301, which is 59. So that's my angle that we're going to use. And then I can use diameter here just fine. So here we go. We take our angle, 59 degrees over 360, and that's times pi times 20. And we type that into our calculator. So 59 divided by 360 times pi times 20. And we get 10.30. And that would be meters. All right. So that's another example. The last kind of thing that we could end up seeing is if we are given the arc length and some other information and we want to find either a radius, a diameter, or the angle of the arc. So just like when we were doing area, circumference, and all of that, we want to go both directions. We want to be able to find area and circumference and also use those to find radius and diameter and things like that. So same idea here. Wow, that's not going to go to the center of the circle. There we go. Let's say I know that this arc length is 200 feet. And I know the radius is, let's see, something reasonable. One moment. Let me see if I can pick a reasonable number here. Let's say the radius is 92 feet. Okay, so from here, I would want to find my one missing piece of information, which is the angle. So to do that, I know this is my arc length, so that's what's going to be equal to my equations over here. And then I'm going to use one with radius in it because this is a radius. So we're going to go 200 equals theta over 360 times 2 times pi times 92, since that's my radius. All right, so now I have to solve this thing for theta. So you can do this any order you like, pretty much. But we need to basically get everything over here except for theta. So to kind of take care of the 360 first, I might multiply by 360 on both sides to get rid of it since it's divided by 360. And then, so let's see, 360 times 200 gives me 72,000 equals 2 pi times 92 times theta. We still have all of that over here. So then I just have to divide by 2 pi and 92. But I have to make sure that each of these are divided over here. So when you type it into your calculator, you need to make sure, especially if you're using a phone calculator, you have to go divided by 2, divided by pi, divided by 92. If you're using a regular calculator, put it all in parentheses. So like go divided by, but then put all of this stuff in parentheses. Okay, so here we go. Divided by 2, divided by pi, divided by 92. And we get 124.56 degrees for theta. Okay, so again, a lot of where people get hung up on this kind of stuff is with the algebra. So we want to make sure that we can set things up correctly and plug things in, but also that we can do the steps correctly to isolate theta at the end. Okay, so if you have any questions, feel free to send me an email, comment below, or come to office hours for today. Have a good one.